and welcome back. Today we are covering lesson 96 and learning about graphing quadratic functions. And you know by now that graphing quadratic functions, we could also say that as graphing parabolas. So we are going to dive into graphing the parabolas. Up until now, we have looked at what are quadratic functions in general and reminded ourselves of the standard forms of quadratic functions. And then in our next lesson, we learned about identifying characteristics of quadratic functions. Specifically, we looked for the vertex or the turning point. We looked for the x-intercepts or the zeros, and we looked at the axis of symmetry. And we practiced looking at a graph that we were given and identifying some of those characteristics. But now we're going to go the other direction. We're going to create the graph ourselves. And there is a very specific set of steps that you can use to graph a quadratic function. So we're going to do several examples in this lesson. We're just going to jump right into the examples and go through those steps. And once you've done it a few different times, you'll get more comfortable with going through those same steps for every quadratic function. And just as a note, because graphing parabolas is more work than graphing lines, because it's a more complex function, so that does make sense. But sometimes it can be hard to remember those exact steps or remember what all the terms mean. And so in the module for this week, I have a PDF with all that information, with the definitions of what the parts of a parabola are and the steps for graphing a parabola. And so you can look at that PDF, you can print it out if you want to have a reference where it's all the information is in one place for you to go from if your class notes in your textbook aren't quite cutting it. So go look in the module and you can find that quadratic function overview PDF as an additional tool to help you work on graphing quadratic functions. And so let's just dive right into some examples. So we want to graph this quadratic function. Y is equal to x squared minus 6x plus 4. And so we want to first, before we do anything else, check that it is in standard form, and yes, it is. And so the first step, the first piece of the puzzle that we're going to find is we're going to find the axis of symmetry. And the axis of symmetry, remember that we write that as the equation of a vertical line, which is x is equal to something. And we have a formula for the axis of symmetry that we can use. So we didn't really cover what the formula was when we talked about the axis of symmetry. We just talked about what it was in general. But now we get to learn the formula. And so the formula is equal to negative b over 2 times a, where the b and the a come from the standard form of our quadratic equation or quadratic function. So it's negative b over 2a. And so in this case, we have negative, and then b is equal to negative 6, 2, and then a is equal to positive 1. And that is equal to positive 6 over 2, which is 3. So my axis of symmetry is at the line x is equal to 3. So we're just going to keep that piece of information handy. So our next step is going to be to find the vertex of the parabola. And the vertex, we know, is going to be where the axis of symmetry is, right? Remember that we have the parabola, the axis of symmetry, and it passes through that vertex at the turning point of the parabola. And although the axis of symmetry, that's a line, it's a vertical line, sort of an invisible vertical line, really. But it's at x is equal to 3. That's at, let me redraw that little parabola that I had with my vertex and my axis of symmetry. So we know the x value of that point, but we don't know the y value of that point. And the vertex, we need to know the x and the y value, because we need to know the actual point, not just where it is on the x-axis. But we're already halfway there, right? Because we know that x value. So to find the vertex, we substitute in the x value from the axis of symmetry. So we have y is equal to, and we're going to use our original equation, so positive 3 squared minus 6 times positive 3 plus 4. That's equal to 9 minus 18 plus 4, and that's equal to negative 5. So my vertex then is at the point 3 from that x value, and then negative 5. So we've done our work to find the axis of symmetry and the vertex. Next, we need to find the y-intercept. So you might be saying, wait a minute, we didn't find the y-intercept last time. We found the x-intercepts. And although we did practice identifying the x-intercepts, it's actually a little tiny bit harder to find them without looking at the graph. There's a little bit more work involved, and we're not quite ready to do that work. So although it's good to be able to look at the graph and identify them and check and see if our eyes are telling us the truth about where the x-intercepts are, and it's important to understand what they are. In terms of graphing a parabola, the steps of graphing a parabola, again, we're not quite ready yet. But the y-intercept, we can do that. So again, let's think about our parabola on a graph. Our parabola is something like this, and it's going to cross the y-axis somewhere. But anywhere that it crosses the y-axis, or intercepts the y-axis, x is going to be equal to 0. Right? And this is something that we already know and understand from graphing lines. So in order to find where the y-intercept is, we simply substitute in x is equal to 0. So if we do that, we take the original equation, y is equal to 0 squared minus 6 times 0 plus 4. So, and that is equal to just 4. So the y-intercept is at 0, comma 4. And then lastly, we need 2 more points. So that's all we need. We need 2 more points. And we want to try to pick points that are easy for us to calculate from the equation. So I have run out of room on my whiteboard, as usual. So I'm going to erase some of this, but you would have all this on your paper. Hopefully you already do have it all on your paper from taking notes in class. And I will rewrite some of this as we go. But our fourth step is to find 2 more points. And we want to try easy numbers. Try easy numbers. I'll write that out as a note for us. And so I'm going to try x is equal to 1. So I want to find what is y when x is equal to 1. So that would be 1 squared minus 6 times 1 plus 4. And 1 is an easy number because it's easy to plug in and calculate. So this is equal to 1 minus 6 plus 4 is equal to negative 1. So we've got 1 comma negative 1. And we're going to stop there, and you're going to see why. Although, yes, I said 2 more points, we kind of did find 2 points. It's a little bit of a mystery, but it'll make more sense once I actually graph it. So let's quickly summarize the results of our 4 steps. And this is kind of how I suggest you organize your paper. So unfortunately, my screen is very wide and short, but your paper that you're working on is the opposite. It's nice and long and a little bit more narrow. So I recommend numbering your steps, doing your work on one side of your paper, and then having your graph on the other side of the paper, or using the top half of your paper for your steps and then the bottom half of your paper for your graph. So our first step that we did was to find the axis of symmetry, and that we found was equivalent to the line x is equal to 3. The second step that we did was we found the location of the vertex, which is at the point 3, negative 5. The third step was to find the y-intercept, which was at the point 0, 4. And the fourth step was to find some extra points. Extra point / points. And we found 1 point. We found, positive 1 and negative 1. So now it's finally time to graph. You're probably thinking it's about time. So we get our axes ready. And I simply need to mark each of these points here on the graph. So the vertex is where I like to start. So it's at 3, negative 5. So positive 3 and then down 5. 1, 2, 3, 4, 5. So there's our vertex, and I'm just going to check it off to tell myself that I did that. So the axis of symmetry is at x is equal to 3. So it's a vertical line along x is equal to 3. And I use a dotted line because, again, it's sort of an imaginary line that we acknowledge is there, but it's not actually part of the graph. The y-intercept is at 0, 4. So that's 0 on the x-axis and then up 4. So 1, 2, 3, 4. And then the last thing we have is this extra point / points. So we have 1, negative 1. So I've got that point. So you can kind of start to see we've got half of the parabola going on here, which is good. What about the other half? Well, remember that parabolas are symmetrical. So this extra point that we found, I can simply mirror it on the other side. So this is at y is equal to negative 1, and it's 2 spaces on the x-axis away from the axis of symmetry, so I can just do the mirror image. And then this point is at 1, 2, 3, 4, 5, negative 1. So I did, by finding 1 point, I actually found 2 points because I can mirror it. And I can also mirror the y-intercept as well. If sometimes that's helpful to draw a smoother graph. I always joke with my students that it is hard for me to draw perfectly symmetrical graphs. I think I'm a mathematician, not an artist. Plus, drawing on the computer is a little bit of a challenge. So we'll see how smoothly I can graph this, but I will do my best. And that's what I ask for you to do in your homework as well. Just do your best. It doesn't have to be perfect, but it should look like you tried. So there's one half of the parabola, and then let's see if I can get the other half looking pretty smooth as well. That's pretty good. It's a little pointy on the bottom, but it's pretty smooth. So we've graphed our parabola. So 4 steps. And we took our time going through the steps this time so that I could explain what each step was. But as you go through this, you'll get faster and faster, and it won't feel like such a foreign process. So let's graph another parabola. To graph, y is equal to 6x squared minus 2. Now I noticed before I start anything else that I don't have a term with just an x in it, but it sometimes is helpful to go ahead and write that term, but with a 0 coefficient, so that I can just visually see that it's there, it just has a 0 coefficient. So first I want to find the axis of symmetry. And that is equal, remember, x is equal to negative b over 2 times a. So in this case, my b is 0. So I have negative 0 over 2 times a, which is 6. But 0 divided by anything is just going to be 0. So does this mean that I don't have an axis of symmetry? No, it simply means that it's just going to be at x is equal to 0, which is the y-axis. So my next step is to find my vertex. So I use the x value from the axis of symmetry that I found and plug that in. So that's equal to y is equal to 6 times 0 squared minus 2, or 0 minus 2, which is negative 2. So the vertex is at 0 for x and negative 2 for y. So that's the location of my vertex. The next step is to find, of course, the y-intercept, which remember is where x is equal to 0. So we have y is equal to 6 times 0 squared minus 2. That's equal to negative 2. So my vertex and my y-intercept, it looks like they're the same thing. And you might be thinking, is that wrong? And it's not wrong, because we saw from the get-go that our axis of symmetry is the y-axis. So this is just a really nice centered parabola, and everything is just right there on the y-axis. And then the fourth step, recall, is to find the extra points. And I always like to just pick x is equal to 1, because almost always that's just really easy to substitute in. So if I do that, y is equal to 6 times 1 squared minus 2. That's equal to 6 minus 2, which is equal to 4. So that 1 point, one of the extra points, is going to be 1, 4. All right, so we've got all these pieces, and let's see if we can kind of squeeze the graph in over here on this side of my board, so we don't have to erase everything and start over. All right, I think we can do it. So our axis of symmetry is at x is equal to 0. The vertex is at 0, negative 2, so that's right here. So again, our axis of symmetry, which is simply a dotted line, is going to be right along the y-axis. My y-intercept is also at 0, negative 2, so it's also there. So because, and we said that can make sense because this parabola is just centered on the x-axis. So now I really need these extra points, though, that I found in order to get a good graph. And I found one at 1 and positive 4, so I need to go up 4. 1, 2, 3, 4. And then remember, I can mirror that on the other side of the axis of symmetry. So this is going to be sort of a tall and narrow parabola, something like this. There we go. And there's our parabola. Now, one of the things that we are not really including in our graphing process is whether it opens up or down. Because honestly, by sketching through the points that we're defining with these 4 steps, it will open up or down automatically. So we don't have to do an extra step. But we can always use that as a little bit of a reality check. Did we graph it correctly by looking at that first coefficient? It's positive. The parabola I graphed opens up, so it gives me a little bit of confidence that I at least have that part of it right. And that's it for this lesson, and I'll see you next time.